Here we have AP calculus AB problem. Okay, let's go to the question. The graph of the function f shown above consists of three line segments. If g is the function defined by g of x equals to integral 2 to x f of t dt, then g of negative 3 equals to. So we have to evaluate the value of g of negative 3. Okay, for that let me consider the given function g of x, that is g of x equals to integral 2 to x f of t dt. Okay, here g of x is a function of x. Since g of x is a function of x, so the stuff we have that is equal to g of x must be in terms of x. And also we can consider the definite integral we have over here that is equal to g of x. Here the lower limit of the integral is a constant, the upper limit is x. So the result of this definite integral must be in terms of x. Since g of x is a function of x and also the result of this definite integral must be in terms of x, we can write this function g of x as g of x is equal to integral 2 to x. We can replace the t over here and here by x. Then I'm getting f of x times dx. Okay, from now I'm going to consider this definite integral for g of x. Okay, now let me consider the question, that is we have to evaluate the value of g of negative 3. Let me write it over here. Okay, g of if I want to get the value of g of negative 3 in the function g of x over here, for x I have to plug in this negative 3. Okay, when I do so, on the right side for this upper limit of the integral I have to plug in negative 3. Then I'm getting integral 2 to negative 3 f of x dx. Okay, here it's a definite integral because we have the limits. The lower limit is 2 and upper limit is negative 3. Usually in a definite integral, the lower limit will be a smaller number and upper limit will be a bigger number. But in this case, the lower limit is a bigger number, that is 2, and upper limit is a smaller number, negative 3. So before we start evaluating this definite integral, so we should be getting the lower value, I mean a smaller value as a lower limit and a bigger value as the upper limit. For that, what we have to do is we have to switch the limits. Okay, when I switch the limits, what will happen? Let me do it. So that is, let me write this upper limit negative 3 as the lower limit and the lower limit 2 as the upper limit. Okay, in a definite integral, whenever I switch the limits, the sign of the integral will change. So here already we have positive sign. There is no sign, we have to assume there is positive sign in front of the integral. Since we have switched these two limits, we have to change this positive sign as negative. Then we get negative. Now we have to write this stuff as it is. It is f of x times dx. Okay, now how do you have to evaluate the value of this definite integral? Actually, this definite integral tells us the area between the graph of the function f of x and x-axis from x is equal to negative 3 to positive 2. Okay, now let's go to the graph and let me consider the lower limit negative 3 and the upper limit 2. So lower limit negative 3 is over here on x-axis and the upper limit 2 has to be between 1 and 3, because here at this point the x coordinate is the value on the x-axis over here is 1, and here we have 3 as x coordinate, so the value on the x-axis over here is 3. Okay, now we have to get the upper limit 2 on the x-axis, so it's at the exact middle of these two values 1 and 3, so it's over here. Okay, now let me draw a vertical line at x equals to 2, so let me draw it, and also let me draw a vertical line at x equals to negative 3, that's the lower limit of the integral. Okay, now we have to get the area from x equals to negative 3 to 2 between the graph of the function f of x and the x-axis. So here we can split up this area from negative 3 to 2 into 3 parts. Okay, let me draw one more vertical line over here. Okay, so here this is the first part, this is the second part, and this is the third part. Now I have to get the areas of all the 3 parts and add them to get the value of this definite integral. Okay, now let me consider the area of the first part we have over here. So here what's the value we have on the x-axis? For that, let's consider the x coordinate over here, that is negative 1. So the value on the x-axis over here is negative 1. So what is the length of this line segment? For that, we have to find the distance from negative 3 to negative 1. Clearly, it's 2 units. And so what is the length of this line segment? For that, we have to consider the y coordinate at this point, that is 2. So the length of this line segment is also 2. So clearly, this is a square. Okay, now to get the area of the first part, we have to find the area of this square. The formula to get the area of the square is a side by side, that is 2 times 2 is 4. So the area of the first part we have over here is just 4. Okay, let me write the stuff over here. We can take this negative sign as it is. Okay, now let me get the value for this definite integral inside the square bracket. So now the area of the first part is 4. And also here I am taking positive 4. Whenever I get area for a particular part above the x-axis, when I evaluate a different integral. So when the area is above x-axis, the area should be considered with positive sign. Okay, now let me get the area of the second part we have over here. Clearly, it's a right triangle. So this is the base of the triangle. This is the height of the triangle. Already we know that the height of the triangle is 2 units. So whatever length we have over here, the same thing. And the height of, the base of the triangle is, let's measure the length of this line segment. That is just 1 unit because here we have -1. What is the length of this line segment? This is also 1 because here we have 1. So the total length of this line segment is 2. That is the base of the triangle. Okay, now to get the area of the right triangle, that is area of part 2 is base times height divided by 2. The base is 2, the height is also 2 divided by 2. So I just use the formula to get area of a triangle. Base multiplied by height divided by 2. Okay, and also we find the area of the second part also above the x-axis. So we can take it with a positive sign. Okay, now let me go to the area of the third part. So here this is also right triangle, and here the base of the triangle is the distance from 1 to 2, that is just 1 unit. And to get the height of the triangle, we have over here, we have to consider y coordinate here, that is -1. So clearly the height of the triangle is also just 1 unit. So then the area is the base 1 times height 1 divided by 2. But here we find the area of the third part below the x-axis. So this area should be considered with a negative sign. Okay, now we have to simplify the expression we have over here, negative. We can take this 4 as it is positive, and this 2 will cancel. We get 2 negative. 1 times 1 is 1 divided by 2. Then we get a negative 4 positive 2 is 6 and negative 1 over 2. Here I do subtraction between an integer and a fraction. Whenever I want to do addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I am done with the multiplication, I can take this 2, the existing denominator, as a common denominator. Okay, let me do it. Then 2 times 6 is 12, negative 1. Now we can take this 2 as a common denominator. Then I'm getting negative. So 12 negative 1 is 11. And in denominator we have 2. Okay, I got the value of g of -3. Its value is -11 over 2. We find this stuff -11 over 2 in answer choice B. The correct answer choice for this question is B.